Hello, this is Group Old Boys, and our presentation is about water level control by using PLC. Wastage of water is a huge problem these days when we feel the effects of global warming a lot. Thus, it has become more important than ever to protect the water because water is an important resource that we use in many areas, such as agriculture, industry, and household, etc. The starting point of our project is to find solutions to the waste of water. To be able to do this, we are going to use PLC to control the level of water and avoid wastage of water. The system starts working with a start-stop button. Sensors are automatically begin to work. Low level switch is active. The pump will work. Controversially, when high level switch become active, the pump will stop.
When the system reaches 250 centimeters, the speed of motor is reduced to slow down to the pump. When drain pipe is activated, the pump stops for 15 seconds and the water is drained. If the temperature drops below 5 degrees, the heater works. That's our HMI. Because of the ladder diagram was created as online simulation, we weren't able to design a working HMI. You can see the sensors and elements of the structure symbolically and schematically. And let's look at our.
So we are going to start our program by pressing the online mode button. Then we are making sure it is running. Then we're going to press the start button. This is going to trigger the pump. Triggering the pump activates this pulse output function. This function helps us start the servo motor, which is very important for the pump to start. These variables here are crucial for the servo to start. Our water level is at half when the program starts. So, low level switch is true while the high level switch is false. After we start, the water level will rise. Then, high level switch will be true. This will activate the motor stop signal, which helps us stop the motor. Now we can open the valve that goes to our home. Let's assume that we saw the water was not clean when it came to our home. We will close the home valve. Then we are going to activate the discharge mode. Opening the discharge valve will make the water level drop. First the high level switch, then the low level switch will be false. When the low level switch becomes false, our timer here will keep the discharge valve open for 15 seconds to make our tank completely empty. When the tank is empty, we exit the discharge mode. The pump starts again as well as the servo motor. First the low level switch, then the high level switch becomes true and motor stops again. If any one of these processes go wrong, we can press the emergency button. This button closes the pump and the discharge valve if they're open. We have two analog inputs in our program. The first one is this one. This input shows us the exact level of the water in our tank. We are putting the number 2 here to this config because we want our input between 0 and 10 volts. We are doing a simulation, so let's say analog inputs and analog 2 inputs have same value. This water level scale is one of our own functions. So let's put 5 here. The water level becomes 175. Let's put 8 here and the water level becomes 265 and this function starts. So if this water level is higher than 250, these functions send a signal to slow our motor. 250 is just under the high level switch because we want our motor to not stop instantly, we want it to stop slowly. We are doing our PID control here on the heater. This is our second analog input the thermocouple. It's our temperature sensor. This PID is connected to our heater signal. We control the heater by PID. When this value gets where we want, the PID closes the heater. Since we can't get any input from the system because it's just a simulation, we did our own function block here, this dynamic heater. So let's say we put here a number. Let's say we put 0. It automatically increases it to 6. So if we put any number lower than 6, it increases it. When the heater closes, we reset the control signal for the next operation by this function reset control 1.